The objective of the following case is to introduce users to the heat exchanger environment, which will allow users to better represent the heat exchanger network in a SAGD CPF. In a SAGD CPF, heat exchangers are used to preheat the BFW before sending to OTSG. This is to ensure optimum operating temperature of the unit and to maximize the amount of steam produced to circulate back to the well pad to extract oil. By incorporating heat integration through heat exchangers, a process can be optimized to recover waste heat within the facility and utilize it to increase the temperature of cold streams when needed and vice versa. Currently, BFW temperature is estimated using heuristics from concepts such as the pinch analysis, which reduces the overall minimum approach temperature to improve energy efficiency. The degree of heat integration can be improved by moving the slider to the right to increase heat recovery. Another feature in In Situ Sim is having user-defined heat integration by using the heat exchanger network to add heaters, coolers, and exchangers. This gives the user the power to decide where they would want to put heat exchanger equipment within their process. Enter the heat exchanger environment by clicking Heat Exchanger Network in the top right corner. When entering the heat exchanger environment, you will notice that the streams change to different colors. Blue-colored streams within this environment are cold streams, which are those that need to be heated. Red-colored streams within this environment indicate hot streams that must be cooled. This shows a user where a heater, cooler, or exchanger can be added. Heaters can only be added to blue-colored streams, and coolers to red. When you double-click on a heater or cooler, the general properties of the equipment will show, as well as the inlet and outlet stream specifications. Exchangers appear with a link when first placed. This is to remind users that an exchanger needs a hot and cool side in order to operate. As seen, the link must be dragged and attached to another stream of the opposite color as the current stream it is attached to. Same as the heaters and coolers, when you double-click on an exchanger, the general properties will show, as well as the characteristics for the inlet and outlet streams. In In Situ Sim, heater, cooler, and/or heat exchanger, if connected to a block with a specified temperature, will already have target temperatures to reach due to the specifications within the process block. Other times, the user will have to specify a target temperature to ensure enough variables are defined to solve the case. Before comparing a case without and with heat exchangers, let's look at the heat imbalance identified by In Situ Sim. In Situ Sim has the capacity to identify where heaters and coolers are needed and the duty to heat or cool a stream. First, let's run the base case as is. Now let's access the heat imbalance page by going to the Reports tab, under Energy Losses, and Heat Imbalance. Expand the heaters and coolers. This will display the stream type, where the stream is coming from and going to, the temperature of the stream at the location it is coming from, and the temperature it should be at the next piece of equipment, and the duty to heat or cool the stream. This helps identify where a heater or cooler is required. Let's solve the base case with average heat integration using heuristics and compare the results with average heat integration using heaters, coolers, and exchangers incorporated in the heat exchanger environment. We can view the results by going to the Reports tab. In the Reports tab, you can view the BFW temperature and the fuel gas usage in the Energy Efficiency tab. The direct GHG emissions can be found in the GHG emission tab. The comparison of the base case and the base case utilizing the heat exchanger environment is shown in the following chart.